Random noise is incompressible. It is as far as things can be reduced. It is the limit of our ability to comprehend and make sense of. This is also what we think the vacuum energy quantum foam is: random noise. Interesting how these are connected. Does our inability to make sense of data mean it isn't data anymore? Is looking at smaller parts of reality not just the decompression of data? So what I'm saying with this is that I saw a 3 blue 1 brown video that was talking about data compression. And I'm really not a computer science person. I'm not super savvy with programming and things along those lines, and working with data. However, I thought that this was an interesting point, that the ideal data compression is basically random noise, because past random noise, how can you decode it, right? If it's decompressed, if it's compressed all the way down to random noise, how do you uncompress it, right? How do you make sense of basically random noise? And so I thought this was interesting, because when we look at smaller and smaller scales, right, we look at the world, like the universe, right? We look at the world, and at a certain point we say it's just random noise, right? And so what if that's just the limit of what data is decompressible for us, right? After a certain point, the data is so compressed that it loses all meaning. It just becomes random noise, right? And so what if the reason why it appears like random noise to us is because the data is too compressed, basically, for us to resolve what it means, right? Because when you think about looking at smaller and smaller scales, right, we're trying to, we use like high amounts of energy and like these special microscopes and things to try and see at smaller and smaller scales. What are we really doing? We are decompressing the data, right? We are something that has been compressed down to a pixel. We are trying to blow up into a full image, right? But after a certain point, right, the data just is lost. It's uncompressed. It can't be expanded, right? It's just random noise, right? And so what I was thinking about is well, what if that's just how reality is, right? What if the reason why we think that the quantum foam is random noise is because it's just, past the limit of data that can be, extrapolated, right? We don't have enough information to decompress any farther. However, if we got enough data, if we had enough information, I think that we could eventually figure it out. But I don't know, right? And I don't know if it even makes sense to, right? And so I just wanted to talk about that. I don't know if I really have anything else to say about it. What did I write? What did I write at the end? Just double check. Does our inability to make sense of data mean it isn't data anymore? I feel like this is an important question to ask here, right? Because if you take an image and then you compress the image down, right? But then when you go to, uncompress the image and try and get the image back, right? Data is lost and it's more pixelated than it was when you first compressed it, right? Does that mean that that's no longer, like, that data that got lost is no longer data? Or was it just that it was no longer data we could, decipher, right? And so that I just think that it's important, because it's not that the information, like, in theory, the information is lost, but the information went somewhere during the compression, right? And so if you had a better um, compression algorithm or whatever. I don't, like I said, I don't know the technicalities of this, but if you had a better method for compression and decompression, then that data wouldn't be lost anymore, right? And so I think that there's potential for us to decipher further than what we currently think the limit is. But we just haven't figured out the proper equations, the proper algorithms for that, right? And so when we have the proper coding and process down, I think that we will find that there is more information to be recovered from what we're looking at, right? We thought we got all the pixels out of the image, right? We thought we recovered it at 100%, but there's actually realistically infinite information to still be recovered. However, do we actually need infinite information? No. In theory, no, we don't need infinite information to know what the image is, right? If we have a certain amount of information, getting infinite more data is not going to make the image any more comprehensible, in theory, right? I guess we could go into this a little bit, right? So if I have an image, right, of a cute cat, right? And then that image gets decompressed down, right? And then, say it has infinite pixels, right? However, do we need to break it back out into infinite pixels, right? If it goes from infinite pixels, gets collapsed down into, I don't know, say 10 pixels, right? That's a significant compression, right? But if we have a good algorithm or whatever for decompression, right, we decompress it back out to 10,000 pixels. Is the image at 10,000 pixels truly that inferior compared to, infinite pixels? Because if you think about it, right, say 10,000, you could probably figure out, okay, this is a picture of a cat, right? But say we figure out, okay, we can get it to 100,000 pixels, right? I'm thinking that after 100,000 pixels, you have a pretty good idea of what the image is. Okay, this is definitely a picture of a cute cat. There's really not that much more to be gained by adding more and more pixels or trying to figure out how to get more and more of the pixels back, right? Because after a certain point, you don't even notice the differences that are happening, right? You're like, okay, we just made it 1,000,000 pixels, but can you really perceive the difference? Does it actually change the image? Do you get any more information out of 1,000,000 pixels compared to 10 to 100,000, right? Is there actually a substantial difference between those two, right? Was there any understanding that was enhanced? And I think the answer is just that no. There's really there's a limit to how much information can be gathered from digging deeper and deeper into that process and trying to get more and more of the pixels to be resolved, right? Because at the end of the day, you're never going to get to infinity. There's infinite pixels there, right? You will never truly have all the information. But at what point are you at diminishing returns? And I think that, bringing it back to reality, I think we've already hit diminishing returns. And so I don't think that adding more pixels to the image is really going to change your understanding. If we want to understand the image better, we just need to look at this image of the cute cat and be like, okay, well, what can we learn from what we have, right? What can we learn from this image, right? We know it's a cute cat, but what does the cute cat mean? What does it mean? What is a cute cat? How do we know that the cat is cute, right? And we start asking these philosophical questions, right? We stop focusing on the physical makeup of the image, right? How the image is constructed, all the little pixels that make the image. And we start thinking about the image itself and what the image means and how it makes us feel. And, what can we take away from it? What lessons can be learned from this image, right? Rather than focusing on what is actually physically there, we start thinking about how it impacts us, right? How it makes us feel. That's where we're going to get more understanding. That's where we're going to learn more, right? And it's not necessarily this analytical scientific process, right? And that's the problem, that's the part that makes everyone so uncomfortable, because, you know, everyone looks at philosophy and goes, that's not science. But that's not true. Science is philosophy. Philosophy is not, it's not really science. It's more, right? You can't say philosophy is science, but science is philosophy. It's just a very limited scope of philosophy, but it all falls under the philosophy umbrella. That's where it developed out of. Science comes from philosophy. People thought about the meaning of the world and the universe and how it became to be and how it all works and stuff. And over time, we developed science. And then we threw philosophy out the window and we said, that's no longer valuable to us. Science is all we need. But we've forgotten where science comes from. And I think we need to remember, because without remembering the roots of science, right, if we ignore the roots and, you know, a tree who can't grow, whose roots are neglected and don't continue to grow, cannot grow larger, right? If a tree tries to grow higher without growing its roots, it just doesn't work, right? Or, you know, what happens is that a wind comes and it blows it and it falls over, right? In order to sustain a bigger tree, you need a bigger root system, right? And philosophy is the roots of science. So without expanding philosophy and growing that field and not neglecting it, right, we will never be able to advance further in science, because that's just how things work. That's just how it is, right? Because without thinking about things to explore, you cannot explore them, right? If you don't have concepts to, you know, test and theorize on, then you cannot go in those directions, right? You can't grow branches and produce leaves and fruit off of nothing, right? There has to be a concept to chase after, right? And so if the roots do not branch out so that there's, you know, stability, so that there's structure, so that there's, you know, a framework in place that can sustain these new branches coming out and these new leaves and these fruits growing on the branches, right, then there will never be those branches, right? And so bringing this, you know, I'm talking about the tree, but the tree of knowledge, right? This is how this works, right? The tree of knowledge is called the tree of knowledge, I think, for a reason. It's because it's very symbolic, right? All of humanity's knowledge and, you know, what we know as a species, as a collective humanity, comes from, you know, simple concepts that have been expanded over time, right? And so, as I said, we started with philosophy, then we started to develop into science, and then science started to branch out into different fields of science, right? And so it all comes from these same places, right? From this single seed that has sprouted this, right? This concept of thought, right? Of thinking about what it means, right? And I don't think we should neglect that. I don't think that should be seen as, oh, that's just, you know, meaningless, you know, silliness stuff, right? I think that there is value in it, and I think that it is worth keeping and considering and all that stuff. So, yeah. Peace out.